Good afternoon, everybody, and we are recording live from beautiful Fredericksburg, Virginia right now. Normally, I would be in our Richmond office next door to my colleague, Joe Wood, who's our guest speaker tonight or this afternoon, but I'll show you. Here's my colleague today. So this is Molly. I told you you'd get to meet Molly. Just a quick logistics note is everybody's on mute right now except for Joe and myself. And so what you're going to do to ask questions is you'll just click on the Q&A button that is down on the toolbar and just post your questions there. Joe can see them and I can see them. And if he knows he's going to cover them later on in his slides, he'll just keep on rolling, or otherwise he'll stop and he'll answer them right there. So I'll give you a tiny bit of background on Joe. So he's a Virginia Tech grad. We're not going to hold that against him because go Wahoos. But yeah, he majored in philosophy. And what's been really neat about having Joe as a colleague is, I guess it's a philosophy major, but he asks these really big questions. And he also taught school, and you'll see some of that in this presentation. And finally, he went and he said, well, enough of school teaching, I'm going to go get my Ph.D. So he got his Ph.D. from VCU. So we're really honored to have him with us today, and he's really excited about mussels, and he does a great job of explaining it. So Joe, take it away.
Thanks, Ann. So hey, everybody, I'm in Richmond, Virginia. I'm a scientist at the Bay Foundation, and the goal of today is really just to spend some time talking about freshwater mussels, and this could serve a couple of different purposes. Hopefully it'll at least be interesting. Maybe it'll be practical for you, interesting in your own work. And hopefully, if nothing else, it'll be a distraction from some of all the other stuff going on in the world today. So today I'm going to be talking about freshwater mussels, and they're just a group of organisms that over about the past 3 or 4 years have just kind of, hooked me, just because there's so many different interesting things about them. And so really today's presentation is intended to just share some of that interesting stuff about why they're important, et cetera. So here is a brief outline of what I'm going to go over today. The first thing I just want to spend some time on is, like, what are freshwater mussels? What does their life cycle look like? What are the things that they do? What is their life history? Then I'm going to spend a little bit of time talking about some of the good things that freshwater mussels do, some of the ecosystem services they provide, and their benefits for water quality. I'm going to talk a little bit about some of the things that are challenging for freshwater mussels, why they're struggling in some places. And then I'm going to close with kind of 2 topics. One, is there anything we can do to restore freshwater mussels? Is there anything we can do to improve their outcomes? And then lastly, how does that intersect with us restoring the bay, improving our coastal ecosystems? Are these questions connected? Okay, so usually when I bring up freshwater mussels with folks, one of the first things they say to me is, "Oh, you mean like on a big plate of spaghetti, right?" And that's not the group of organisms we're talking about. Those are blue mussels. They are found in North America along the eastern coast, but that is a different class of organisms altogether that lives in saltwater. Also, a common species is the Atlantic ribbed mussel, also known as the bay mussel in some places, which is surrounding tidal shorelines often. Again, that's a different organism, different class of organisms, and lives in all brackish or saline waters. I'm also not talking about today some of the non-native freshwater groups of organisms that are mussels. That includes zebra mussels. Many people have heard of the problems that they cause within the Great Lakes. They're severely invasive species, as well as corbicula. So if you've ever been walking around in a stream in the eastern part of North America and found a mussel, it was probably this guy, which is actually an Asiatic clam. It's got these deep ridges in the shell. They can get to be, I think, about the size of a quarter, maybe a little bit bigger. Very common, but a different class of organisms. The group of organisms I'm going to be talking about is Unionidae, is the group of organisms. And they are restricted to fresh water, and they have a much different look than some of these other mussels. Their shells almost have this papery feel to them. There's this outer covering that kind of flakes off if you ever see it, and there'll be a lot of this white underside exposed. There's another group of native mussels to North America, the fingernail and pea clams. That's a different class as well that we're not going to be focusing on. So that's the group of organisms that I'm talking about today with this presentation. So if you look at Unionidae and freshwater mussels across the globe, there are, give or take 300 to 400 species across the globe. And we, in the United States, we live in the hottest place for these mussels. There are nearly 300 species alone in the United States. So the United States and North America are the richest area in the globe for freshwater mussels. If you then were to zoom in to the United States and say, well, where does the diversity exist across of our nation? This map shows color-coded the number of species per state, with the darkest red being the highest. And by far the most diverse area in the country is sort of this Tennessee, Kentucky, Alabama, even the southwestern tip of West Virginia and Virginia. The Clinch River Basin is likely one of the most biodiverse rivers in the world, and as well as parts of the Ohio and the Mississippi drainage. But the Bay watershed, if you look at it from a global perspective, has pretty substantial diversity. If you look at a state-by-state basis within the Bay drainage of those areas, we have 49 different species of mussels just in the watershed alone. And this map essentially shows where those are by state. Even the District of Columbia on the Potomac River, there are 15 different species found in the district alone. So there's a lot of interesting stuff going on with freshwater mussels in the Bay watershed, and a lot of diversity to protect. So one of the first things that stood out to me when I saw this map was, well, why is the Southeast so popular for freshwater mussels? Is there something about, soul cooking they like, Southern food? What is it? What's going on there? And no one really knows, but one of the hypotheses that's been postulated and discussed has to do with the ice ages. And so what you should be seeing here is a time-lapse video of the last several millennia of ice ages encroaching and retreating. And so this perspective is looking at the globe essentially from above the North Pole. So on the right-hand side of your screen, you should see the United States. And I find looking at kind of the panhandle of Florida as the easiest kind of designation. You can also see kind of the Gulf of California on the southern side there, or on the lower side. And so the hypothesis is that the reason that Southeast area is so diverse is that, as these glaciers and ice ages covered these periods of land for long periods of time, there were a lot of mussels that were probably extirpated. And this really isn't just freshwater mussels. There's a lot of other freshwater species as well. But the Clinch River and some of those rivers down in Alabama were essentially, not exposed to that extreme weather. So that's at least one explanation as to why the diversity exists the way it does in our country that I always found interesting. Okay, so I want to spend a little bit of time talking about just giving you a look at what do these organisms look like. And so I'm going to play a video of some mussels in an aquarium that I took about a year and a half ago. And you should see a group of freshwater mussels, and then this tongue-like appendage that is extending from it, or this thing that's sort of flailing around with an eye spot on it. And so I'm going to ask you in a second what you think is going on with this picture. So just observe and take a look and see what you think is going on here. So I'll go ahead and get Anne to queue up our first poll question of the day, which is, what was going on in that video? And so the options here are, was that a fish feeding from algae that was growing on a mussel? Or was that a fish caught in the jaws of a mussel that was trying to escape? Was that a mussel using this tongue-like appendage to catch detritus and filter filter algae out of the water column and remove pollution? Is it a fish laying its eggs within a mussel shell so it has protection? Or is something else going on here? So go ahead and put in your votes, and we'll see what folks think is going on with this mussel. Okay, so pretty interesting here. Most people think that this is a filtering mechanism that people are that these mussels are, removing from stuff from the water column with this appendage. I didn't even realize this, but the title of the video actually was a big clue here. It says Pocketbook Mussel Lure Display. And so the answer to this question, those first four things are all just things I made up. Those aren't actually what was going on here. It's something else. And as usual, nature is a lot cooler than the things I made up. So let me show you, give an explanation of what was going on here. Organisms in the class Unionidae have to have a fish host be a part of their life cycle in order to reproduce. And essentially the way their life cycle looks is you have your adult freshwater mussel kind of seen on the lower left-hand side of this diagram. It produces baby mussels known as glaucidia. And then somehow they have to attach themselves to the gills of a fish. And essentially they cling on to it, they suck its blood for a few weeks and they ride upstream. And so why do they do this from an evolutionary perspective? And the fact is that mussels can move, but really not very fast and not very far. But by adapting to hitchhiking or catching an Uber or a fish host, I've heard it described, they are able to travel miles upstream and spread their young in various places. The mussels stay for about a few weeks, and then eventually they drop off as these juvenile baby mussels, and then are essentially just kind of grow into these larger stages. Again, at this point they can move, but it's a very slow movement, probably a few feet on the order of a day. So the correct answer was something else for that situation. And so this is a documentary. I think it was done by the state of Missouri. And I'm just going to fast forward here to show you what this looks like. And so what you're looking at here is a freshwater mussel, a Lampsilis mussel, and then here is a largemouth bass. And you can see that this lure, it's designed to look exactly like a darter, which is a common prey species of largemouth bass. And keep in mind, mussels don't have any eyes. They don't have any way to see, and yet, there's pretty real life fishing going on here. And what's going to happen? This bass is, intrigued. He's going to hit this in just a second. Um, let's see what happens. Okay, so as soon as he hit that, it pops like a water balloon, and that cloudy stuff you're seeing, those are all baby mussels, essentially kind of flocculating to the gills of the fish. And now you should see these little baby mussels clamping down on the gills of the fish. And so they will stick there for a few weeks, and then eventually they'll kind of suck some blood for nutrition and then fall off. People often ask, does this hurt the fish? And generally, from what I'm told, is no. Freshwater mussels, clinging onto the gills of the fish are probably not a bad thing for the fish. And ultimately, freshwater mussels are actually probably good for fish because they have good ecosystem services. A few other things I'll just mention here is that many freshwater mussel species, it can't just be any fish. Oftentimes, it has to be a single fish or maybe a group of fish for the host to work. And oftentimes, there are these symbioses, these evolutionary things that have happened across species where the freshwater mussels will stick around in habitat that those fish like. Their lures, these things that they're flailing around, look like the prey that fish want to eat. So pretty cool ecological stuff going on here. And there's some other adaptations that occur as well. There's even one mussel that opens its shell a little bit, and the fish kind of climbs in, and it literally shuts the fish's head within the jaws of the clam, and then sprays the juvenile mussels into the gills of the fish. So just fascinating stuff. There's another example I'll show here. Then these are called superconglutenates. These things were discovered, from what I understand, only within the last 15 to 25 years or so. So like when we think about like ecological science, oftentimes there's this impression that like we know everything that's out there. But like this, pretty profound species that's, found, around the globe, we didn't know about this dynamic that I'm about to show you until relatively recently. So you can see this fish kind of floating around here. And if you look really closely, you can see that there's almost this like clear tubing that's attached to it. And this is essentially a lure from a freshwater mussel that can extend out several feet. So, I mean, this is literally a fishing pole. They've got a line that's pretty transparent, pretty hard to see, and then their lure at the very end of it. And a fish will come along and bite that, and the same thing will happen. So again, like, not all species have these lure. Many of them do. Some of them have other adaptations. But always there is this link with a fish that the mussel needs to complete its life cycle. Okay, so the first point that I just wanted to make in today's presentation is simply the fact that freshwater mussels are cool. And the more I've learned about them, it's like there are all kinds of facts about them that are just very, very interesting. I also think that they have these really beautiful shells, and there's just this rich diversity of colors and patterns that are very interesting. So that was the first takeaway for today. Um, and so I'm going to go ahead and now move into the second point that I want to convey to you. And that's that mussels are important for some of the good things that they do. Mussels provide ecosystem services. They filter the water. They do other things as well. And I'll take a second here to just make a public service announcement that water quality is suffering in the Bay. It's suffering around the country. Certainly, we've done a lot of good things over the last half century that have improved water quality, but the challenges are growing. There's a lot more people on this planet than there used to be, which requires more food, more energy, et cetera. And our water quality is fairly degraded. The issue that I most commonly work on is the issue of what's known as eutrophication in Chesapeake Bay watershed, where essentially nutrients like nitrogen and phosphorus, things we apply to our lawns or to land to produce food, essentially make their way into waterways. They cause algal blooms to grow, they sink to the bottom, they die, and they start to rot, and they just suck the oxygen out of the water. And many of the fisheries that we care about, whether it's bass or oysters or something else, really suffer. Okay, so in the lens of water quality being a challenge, there are some good things that freshwater mussels do that are relevant here. And so what I'm showing now is essentially just a diagram of like, what does a freshwater mussel spend its life doing? What are the activities that are important? And this doesn't look very different from if you've ever heard of bivalves doing good things. It's fairly similar. These organisms are filter feeders, which essentially means that in order to eat, they suck water out of the water column at a fairly rapid pace. They remove stuff that's could be considered pollution. They can incorporate that into their soft tissues inside of their shells that could actually go into their shells themselves. And then those nutrients, at least some of them, are returned back to the water column. Through the process, they also develop feces and pseudofeces. Their waste is deposited, and usually that is settled out to the bottom. They also do have this movement activity. And I mentioned earlier, it's not rapid. They are not going to move very much. But if you have a whole bed of mussels that's burrowing down and moving up, there is some activity that's happening within the benthos, this area of where the sediments is that could potentially affect what's going on in the ecosystem. And so many of you have probably seen a time-lapse video sort of like this, where you essentially take two tanks, you fill them up with water, the water is cloudy, it's got all kinds of stuff in it, you add mussels to one but not the other, you wait a little while, and of course the water gets clearer in the tanks with mussels. They are essentially removing some of the fine particulate stuff from the water column and either taking it into their shells or depositing it on the bottom. And so mussels are no different than other species in that regard. In order to compare how do freshwater mussels filter relative to other species, this plot comes from one of my partners at the Partnership for the Delaware Estuary, Danielle Krieger. And essentially what it's showing is 7 different species of bivalves and how fastly they clear the water of a given particulate. And so what you're seeing in blue, these are the rates of removal for freshwater mussels of the class Unionidae. Then the red bar is the non-native clam corbicula that I mentioned. And then the 2 green species are the saline species, with the last one being our oysters. And the point here, it should raise a few caveats. With any ecological process like this, it's of course subject to lots of different things that will cause, drastic variability. How old is the organism? Is the organism in a period of its life where it's filtering a lot, or is it slowed down? What's the temperature? What are the water quality conditions like? So these rates are highly variable, and there's a lot of research going on to figure out, how fast different organisms filter. But the main point here is that if you're familiar with this concept of bivalves being good for water quality, you should classify freshwater mussels as an important part of that. They do as well or potentially better than some of these other organisms. Note that these units are in liters filtered per hour per gram of organism. So the size of the organism is accounted for within these measurements. In other words, a small clam isn't discounted because he's just half the size of a large clam. Okay, so they're pretty good at filtering water compared to other species. So if we dive into this a little bit farther and think about, well, what is all this filtering of the water doing? Is this a big deal? Does it just make the water a little bit clearer? Is that the only benefit? And so essentially this diagram is intended to walk you through that. And so just kind of starting on the left-hand side here, again, these organisms are filtering the water, they're removing this stuff. Some of that is assimilated into their soft tissues and hard tissues, but that is a temporary sink. The soft tissues, that's really the life of the mussel. The shells, that will probably be stuck there for a while. It might be a few hundred years, but from a geological perspective, it's still not a permanent sink, at least. Some of this is remineralized immediately. That's probably within a day. Some is deposited onto the sediments in this form of pseudofeces, where they're producing waste, just the stuff that they didn't want to consume. There is potential that might be buried and stuck for a long time. And essentially, the pollution is kind of taken out of the cycle and doesn't have as big of a problem. But again, from a geological perspective, that's not going to be a permanent loss. Whenever there's this massive flood that comes along, those benthos are likely to be disturbed, and that will eventually be lost. The really sweet spot for pollution removal is this last arrow that goes up to the top that says denitrification. And essentially what that is, is that mussels, essentially create this habitat for microbes where they convert nitrogen that is in the water and, can potentially cause problems into a gaseous form, and it's lost from the environment. And that is a completely permanent loss. It's probably a very small proportion of the nitrogen that flows through this system, somewhere in the order of less than 5%. But because the loss is permanent, it's a very, very important component. And just like with oysters, mussels have this capacity to enhance this process of denitrification. It's not exactly clear why they are improving denitrification. Like, what is it about the mussel that makes more denitrification happen? But a few theories that are out there. One is that that these freshwater mussels essentially create a healthier flora of microbes, because they're kind of bringing this rich material down. They're disturbing, causing things to filter up. And they're creating these three-dimensional surfaces that can track biodiversity. So maybe they have caused this rich biodiversity area. The other idea is essentially that this burrowing and in and out on a daily basis mixes things up enough that this process can be increased. But again, that's like an area of really hot research that people are still trying to figure out. And I'd say that's probably true of oysters as well. We know that oyster reefs enhance this process as well, but why is not entirely clear in a pretty interesting area of research. So the main takeaway here is just that mussels do good things. They help, improve water clarity, make it clear. That's good for underwater grasses. They also help remove nitrogen from the water. Okay. Another slide that I borrowed from my colleague, Danielle Krieger at the Partnership for the Delaware Estuary, was really just taking a look at if you wanted to add some mussels to a system, how good would that be in terms of addressing pollution? And I need to start with saying that this is a very preliminary back of the envelope estimate, and could probably vary by orders of magnitude in either direction. But essentially, the numbers that she crunched to ask this question suggested that in order to remove a ton of TSS, or total suspended solids, it would take about $400 per ton of investment. and from a nitrogen perspective, it would be about $15 per pound. And if you think about $15 per pound of nitrogen removal, some of you might be familiar with looking at, the cost efficiencies of BMPs. Maybe not. If you're not, that's a pretty decent removal. And so, these numbers are rough. They're not like, on target exactly. But the concept here is the point that I'm trying to make, and I think that Danielle was trying to make as well, is there is like real economic pollution removal value coming from these organisms. And as such, protecting them is an important thing to think about as we want to protect our water bodies. Okay, there are other ecosystem services as well. The water quality thing is just one of them. Freshwater mussels are certainly a wildlife food source. And it's often challenging probably for freshwater mussels. There's a lot of different things that eat them. They're a very rich food source for snapping turtles or fisheries or otters or a number of different organisms. Probably more importantly, they are a keystone species in the sense that they create this new three-dimensional habitat. And a number of organisms will lay their eggs or spend their lives living within the mussel beds in the same way that we see with oyster reefs as well. And then lastly, freshwater mussels are incredibly sensitive organisms to water quality, and they're really good indicators of water quality, and they're a tool from an informational perspective. In water quality sciences, there's a group of people, a group of researchers that believe that when we take a sample of water and we say what is in this sample, and we try to use that information to assess, how clean is that water body, that there are some real limitations to doing that. Mainly because when we look at a water sample, we are only looking at a snapshot in time. And water chemistry will change literally within minutes, definitely within a day, and over longer periods, absolutely. And there's a group of people that believe that looking at the organisms that live there, whether that's aquatic macroinvertebrates or insects, fisheries, or freshwater mussels, is a much stronger way to assess how clean a water body is. And part of the reasoning for that is that, you can look at a water sample and make a decision about how clean a water body is. But if you look at whether a group of organisms exists somewhere, the determination you make extends across the lifespan of the organism. If you hit conditions that an organism is unable to survive, you won't find it there for the next several years. And so there are a number of things that freshwater mussels are especially sensitive to, and can accumulate in their shells, that makes them very interesting to study, not for their own sake, but to determine how clean a water body is. And I'll just give a brief example of that. In the Allegheny River in Pennsylvania, this story came out about a year and a half ago. Researchers were able to detect fracking chemicals from a decade ago that were showing up in mussel shells. And so, researchers now using mussel shells have this capacity to look at, areas of contamination from a decade ago, which is a pretty incredible finding. Okay, so the second point here is that freshwater mussels do good things, and we should care about whether they exist or not. Even if I didn't sell you on point number one that they're really awesome because they're cool, they've got good benefits for everybody because they're good for water quality, and that's really important for everybody.
Hey, Joe.
Yes.
Let me interrupt you just for a second because you got some questions that are backing up. So I wanted, and before you move on, one of these is really pertinent. So the question is from Grace: do saltwater mussels also need to attach to fish gills?
So at least the ones that I'm familiar with do not. That life cycle adaptation is unique to freshwater mussels. I don't. That's not to say that there are a lot of different species of mussels that exist in salt water, but I think at least for the blue mussels and the bay mussels that they do not. But it's possible that adaptation does exist there. Okay.
And then one more, specifically to the tank. Jean asked, has anyone tried using non-native clams in a tank for educational purposes to demonstrate the filtering capacity of bivalves in general? I know we use oysters that way, but she says, my thought is perhaps using the non-native for something like that rather than disturbing any natives that we come across.
Yeah. I think that would certainly work. I nearly any bivalve will work this. The only challenge is if you can keep it alive. And to be honest, it's probably easier to do that with a non-native species than a native species. So like if you wanted to look for corbicula clams and keep them in a tank, you might want to check with your local game department, depending on what state you live in. In Virginia, there's some restrictions with collecting shellfish. I don't think that extends to non-native species, but you might just be safer to check with them. But yeah, I absolutely think it would work and would work from a demonstration perspective.
Great. That was all. Thanks.
Okay. So point number one, mussels are cool. Point number two, they're helpful. And that leads me to point number three, which is that they're in trouble. And so there are a lot of different problems facing freshwater mussels today. And, I'm going to try to walk through what some of those are. So why don't, Anne, can you go ahead and queue up the next poll question? So the question is, what percentage of mussels do you think that are classified in the category of at least vulnerable, or critically imperiled or already extinct? And we've got less than 10, 10 to 20, 20 to 40, or 40 to 70, or above 70%. And this is the percentage of mussel species that exist.
It looks like most people have voted.
Okay, so most of you are, maybe I gave it away, but yeah, a lot of them are in trouble. So most of you looks like answered 70 plus, and a couple of 40 to 70. Okay, either of those is probably actually an accurate question, but just to show you, to give you some perspective here, what I've got is a plot that shows a variety of different groups of organisms. And then on the x-axis is the percentage of those organisms that falls into one of these problematic categories. Now, blue is the worst category of essentially being like, potentially extinct, or that we know that we think that they were extinct. Red is critically imperiled, orange is imperiled, and then yellow is they're vulnerable to being imperiled. And so essentially, when we look at birds, about 14% fall in one of these categories. If you then expand to mammals, reptiles, dragonflies, you're approaching 20%. Tiger beetles, butterflies, about 20%. Get up to flowering plants at 33%. That's scary. 33% of our flowering plants are, in trouble. That's not a good thing. Freshwater fish, about 37%. Stoneflies, 43%. Freshwater mussels, by far the most troubled organism in our country. And look at this blue bar at the end. Nearly, over 10% presumed or possibly extinct. The red bar also just massive. And so when you think about biodiversity in this country, when you think about classes of organisms that are in trouble, almost double amphibians. Like, think about how much trouble frogs are in, and birds are, and mussels are nearly double that. So incredible potential loss of biodiversity for freshwater mussels could be coming in the next century. Okay, so why is that? I'm going to spend a little bit of time talking about some of the hypotheses. This article actually ran about a year ago on NPR's National Stories about nature's Brita filter is dying and nobody knows why. And that was in response to, there have been a number of situations where freshwater biologists, freshwater ecologists have gone out to a site, a mussel bed, a hotbed for the biodiversity, and just found dying mussels everywhere. And they can't identify a problem. It's not spill related. It's not related to something that's clear and obvious. It's just it looks like it should be a healthy mussel bed, and they're just croaking. And so even though there are these mysterious die-offs, there are some bad things that have happened for mussels that we do know about, and I'm just going to walk through those fairly quickly. So the first thing is historically, and this was back in the 1900s, early 1900s, shells were used to produce buttons, shirt buttons, in the pre-plastic industry. And so in places, there were just these massive, mussel farming operations, and not really farming, collection of wild species. And there's places where you can find these massive, just mountains of old mussel shells that have holes punched out of them for buttons. And certainly this was decimating for many mussel populations. There's probably several species that went extinct, explicitly for this. An interesting fact: apparently, the guy that started this industry died of an infection related to cutting his foot on a mussel called the pink heel splitter. Sort of an ironic ending there. And the estimate is that the value of this industry was about $6 billion. Having done this, I think it would actually be interesting to see what the ecosystem service value of all those mussels that were harvested would be, or if they were still in place. But so this is one historical legacy effect that probably decimated a number of mussel populations. Another thing that we've done that has caused challenges for freshwater mussels is the building of dams. And so dams are problematic for a couple of different reasons. One big reason is due to this host fish issue. And a number of the species that freshwater mussels rely upon are anadromous fish, which essentially live out in saltwater, and then they spawn in freshwater, and then return back down to the stream, or the opposite of that, something known as catadromous. And so American eels are an example of that. And just to demonstrate, the effect of dams in many different places, there are dams that exist, and above the dam, there are no freshwater mussels that exist that are younger than the age of the dam. So essentially, dams have the potential to completely halt freshwater mussel reproduction by cutting them off from their host fish that they need to complete this life cycle. There's some really cool stuff going on above the Conowingo Dam, which is shown here. Colleague at the Fish and Wildlife Service, Julie Devers, and colleague at USGS, Heather Galbraith, are both working to essentially adopt strategies to take American eels, stock them above dams. There's a number of people that have been working on, getting fish around dams for a long time, but stock them with mussels on their gills, so that they can, add a reproductive component. And there's been some success with that recently, although it's a relatively recent strategy. There are other problems with hydromodification as well in dams. Just the change in the natural flow of water cycles has been shown to be problematic for mussels. So dams really a bad thing for freshwater mussels. Habitat is a big challenge. So if you look, across any of the states in the Bay watershed, and really this is probably true of any state in the country, there are substantial, challenges to many of our water bodies. And usually these things are connected to, things we need, our development, food production, or something else. But, essentially there's degradation of water quality, whether that's due to, cows and streams, whether it's due to lots of impervious surfaces that have eroded banks. And we're really just, over the last, I think, 30 to 40 years, figuring out ways to address these problems. But there are a lot of water bodies that still need a lot of work. And so one of the things I want to convey here is that, this issue of our degraded water quality, which was a huge issue for saving the bay, has also been really, really bad for mussels. And so as we move to address water quality in the bay, that has the potential to do really good things for mussels. Okay. And then the last thing, water quality. So there are a number of pollutants by themselves that mussels are explicitly fairly sensitive to. Ammonia is something that back in 2013, the Environmental Protection Agency essentially adopted standards explicitly focused on freshwater mussels, because that life stage I talked about, the glaucidia, that essentially where they're releasing these juvenile mussels that cling to fish, they're very, very sensitive to ammonia. And EPA has established these new ammonia criteria that are protective. In the Bay watershed, a couple states, Virginia and I think Pennsylvania, have moved to adopting these standards, but they haven't been implemented in any state across the country, I think, at least completely. These rules have not been completely implemented. Chlorides from road salt, herbicides, pesticides from lawns or potentially agriculture, sediment and turbidity, temperature, climate change, or just lots of urban flow of water, and pH. All these things have really degraded habitat for mussels and have caused them significant problems. And then there's a number of other issues as well. So disease is an issue that, that's very frequent when you have an organism that's depleted from its historic stocks. So they're in trouble. That's point number three. Potentially just drastic losses in biodiversity, potential drastic losses in this species that is really important from a ecosystem perspective. It does good things for water quality, and there's a number of these species that might not be around anymore. Okay, Anne, do I need to stop for questions again, or maybe?
Yeah, Joe. So there are a couple here. I'll let you read Mr. Garrett's response, and then Bill Barry's got a question just below that.
Okay. When I worked with CB, NERR, and DNR at Patuxent River, Jug Bay in Maryland, we used non-native corbicula for our watershed field experiences in the lab, and it seemed to work well. So there's another answer for that. What is the biomass of freshwater mussels in the Bay watershed, and how does that compare to the biomass of oysters in the Bay watershed? That's a really great question that I've been trying to get an answer to for quite a while. And the answer is I don't know, but I think that it's probably comparable and potentially greater. And so I'll get to that point in just a minute here. At least I'll touch on it. Okay. So let me move in now to this kind of last part, which is essentially, is there anything we can do about this potential drastic loss in freshwater mussels across the watershed? And I should start with saying that, those challenges I talked about addressing, that's probably step number one. Cows and streams, getting, all of our streams fenced off from livestock, that would be an amazing thing to help water quality. Addressing wastewater across the Bay watershed, that would be really good for freshwater mussels. So like addressing the problems themselves is certainly a big part of this. But there's also the component of propagating mussels themselves. And this is technology that's really come along in the past, 20 years or so. So when you think about shellfish in the Bay watershed, oyster restoration is probably what comes to mind, where essentially, we're providing new hard surfaces, providing new spat for oysters. There's a lot of oyster farming that goes on. But when you think about what oysters have done in the last 15 years, it's just incredible. If you think about 15 years ago, we were having conversations about, is there a future for oysters in the Chesapeake Bay? There was discussions of, should we be introducing non-native oysters into the Chesapeake Bay watershed just to improve water quality, and because we weren't sure that the native oysters were going to be able to survive. Fast forward to today, where we've had, what seems like exponential growth of oysters over the past 15 years. And this should be a plug for eating oysters. I know oyster farmers are really struggling right now because of COVID, so maybe have some home parties with oyster platters. But anyways, the point, this is getting sidetracked here. The point is that in just 15 years we've made major progress. Certainly some of that was due to water quality improvements, but oyster restoration has provided major success for the species. Mussel restoration, I'd say, is at least a decade behind, probably a couple of decades. And there are a few things that make it a little bit more complicated. And most of it comes back to this life cycle with the fish, this complicated, life history that we have to address. And so just to think about this in concept, if you start off with an adult mussel, where do you get that? You probably have to get it from the wild. You have to go find it. They're very secretive organisms. They're not easy to find. Even trained experts, will spend a very long time surveying a small area just to try to find these organisms. So you collect this adult from the wild, then you have to do something to get the mussel to produce these babies. I don't know if you set the right mood, play some nice music. In all seriousness, it probably has something to do with temperature and water chemistry and all kinds of other things. So you get it to produce these baby mussels, then you have to get them on the fish, and not just any fish. It's got to be the right fish. And so now you have this element that you've got to raise this whole other organism, and keeping fish in captivity is not the easiest thing in the world to do alongside your mussels. After you theoretically successfully get these mussels to cling to the gills of the fish, you have to catch the baby mussels, which are microns or probably a millimeter in size, and you have to catch them and you have to raise them to adults, and then eventually you have to figure out where to go back and put them. And so essentially this is the cycle that freshwater mussel biologists have been going through. there are a number of propagation facilities around the country. They've been rapidly increasing, in part because, if you think about from an endangered species perspective, freshwater mussels are really important, and there's a lot of regulatory issues that are focused on this. Um, I do want to emphasize here, though, that a lot of the money that is driving this work is not just, hey, let's restore our freshwater mussel populations. It's, hey, this really bad thing happened and there was a mitigation payment required, and so that paved the way for a little bit of money for freshwater mussel restoration. And an example of that is that there was a DuPont settlement in Virginia, in Waynesboro, a few years ago. And this is just, example. There are a number of situations like this, where the Shenandoah River and the South Fork were degraded due to mercury, and there was just decades of aquatic life degradation. And in 2017, when that settlement came out, there was $4 million for mussel restoration to essentially try to put things back together in this watershed. And I guess the point I'm trying to make here is that I'm not sure as a state or even a region that we've made a concerted effort to just put some money into mussel restoration outside of mitigation programs. And so maybe in the coming decades that's something that could happen. Okay, so what do these freshwater mussel restoration facilities look like? Behold the state of art freshwater ecology technology, and it's basically buckets and aquariums. And in all seriousness, I don't mean to poke at the hatcheries. What I really want to do here is point to the fact that these facilities don't have a lot of resources, and they're making a lot of really cool stuff happen that's pretty complicated. But essentially, there are these series of holding bins where they have tanks with fish, and they raise them from very, very small organisms up to very large ones. This is at Harrison Lake Fish Hatchery in Charles City, Virginia, that serves a lot of the region in the Chesapeake Bay watershed. I didn't mention this, but in Pennsylvania, Penvest, along with a partnership with the Delaware Estuary, are working to establish a new hatchery there that should support the Susquehanna Basin as well as the Delaware River Basin. So that's what these facilities kind of look like. Many of these will offer a tour. It's a pretty interesting walkthrough. And so I do want to mention that there are some species that they just have never been able to make the magic happen to get the baby mussels to cling to the gills of the fish. And one example is the eastern elliptio, which is in a lot of trouble, but it's one of the most widespread mussels. And this is a species that usually it connects with the eels that we have, and raising eels in captivity is very, very difficult. So another technology that they're using to propagate mussels is essentially to do this in vitro, and they use a rabbit blood serum to essentially take these baby mussels that they collect and raise them up to a larger size. So some pretty cool work going on here. And honestly, I've got a video here just kind of showing some of these little guys. And you can see, there's some diversity here, just like with people. Some of them are very active, moving all around. Some of them are kind of just like a bump on a log. But pretty cool to see these very small critters that are getting ready to be kind of raised to a larger size. Okay. Another thing that's important at these propagation facilities is making sure what mussel is where. And essentially, so on the left-hand side, you should be able to see this 19 tagged on this mussel. And the way they do this is essentially they have this machine, and there's this row of freshwater mussels that have been propagated here, and they're being scanned, and they get these alphanumeric codes on them that they can identify them for years to come to do all kinds of studies about how many survive, and how well that the restoration efforts are doing. Okay, once they get to a certain size, usually they're kept in these ponds. You can see these baskets that are just floated with noodles, and they get pretty hardy from this perspective. This is not the most sensitive part of their life stage, but the eventual goal is to put them back into native waters. So I do want to make the point here is that this capacity to propagate mussels is new. This is not something that was around 10, 15 years ago. And it's only a piece of the problem, making sure that there's actually habitat that mussels can survive in the first place. That's a big deal. But this is a new tool in the toolbox that, could potentially be a really good thing for freshwater mussel ecology. And there's some really brilliant, hardworking people at Fish and Wildlife and at game departments in the States, and even some locals that are doing some great work here. So it's pretty cool stuff. all that said, usually when I get to this point of kind of this conversation, people are like, all right, give me my bag of mussels. I'm ready to go. Like, I'm going to go put them in my backyard creek. And I guess I just say that mussel ecologists, even though we have this new technology, there's some hesitance here. And that extends back to really just the study of ecology, big thing that you're kind of trained in is that we've tried to create our own solutions in the past a number of times and kind of gone down the wrong road. And so an example is the blue catfish was introduced in the Bay watershed, and it's native to the Mississippi, and it really caused some problems for some other native species. There are a number of other situations where this happened as well. Another example, and this is something that never actually happened, but was the American hippo. And so there was a period of time in this country where meat shortages were a very topical thing. And there was this, contemplation. There were bills passed in Congress related to this to bring hippos down in Louisiana and other parts of the country to both help control an invasive species and also to provide a meat shortage. Lake bacon was the term that they used, I think. And, thank God that never happened. Can you imagine a bunch of invasive hippos running around the country? Like, if that ever caught on, that could have been a really bad thing. I think hippos are like one of the most dangerous organisms in Africa, like on safaris. So the point here is that it's not as easy as like we've got the mussels, let's go stick them somewhere, because ecologists have to answer some of these like really complicated questions. Are we doing negative things to the genetics? Are we, does restocking a species have a negative impact on another? What do we do when we don't know if there's any mussels? And honestly, that's more often than not. And what do we do if there's just nothing there right now? Can you just kind of have free reign, or is it important which species you pick? So all that said, some of this work is happening. This is in the James River in downtown Richmond, where they've done genetics analysis on the species propagated. They know they already exist in the area, and they don't think it's a problem. And so I had a chance to go out last year with some of DGIF, the Department of Game and Inland Fisheries in Virginia, and we stocked about 5,000 alewife floaters to this area. And so Brian Watson, state malacologist, you can see here, scuba diving, checking out the bottom habitat, making sure it's right. And this is just below the 14th Street Bridge, if you're familiar with the Richmond area. So some pretty cool stuff. The last thing I want to mention, I know we're getting close on time, is some work I've been doing about the past year and a half to organize a STAC workshop. And STAC is essentially a science branch of the Chesapeake Bay Program. And essentially, we had about 50 people that met just before COVID kind of disrupted everything, to ask questions about, as of right now, freshwater mussels are not explicitly incorporated into a lot of our Chesapeake Bay work, but should they be? What are the things that we could do that would be good for freshwater mussels? How can we use them as a tool in the toolbox? And so we had a bunch of different people at this meeting from all state malacologists from all the Bay watershed states. We had biogeochemists, we had practitioners, we had regulatory folks at the meeting. And it was a really great, we're still working on, kind of synthesizing the results from that. But I just wanted to go over what that group of experts essentially felt like we should be doing move forward in terms of how do we connect Chesapeake Bay issues with this freshwater mussel issue. And so the first thing was that we need to know where mussels are. And honestly, monitoring for freshwater mussels, these secretive organisms, where they are, what species are where, how many are there, and so how big of an effect are they having, was really, there's not a lot of that data. And can we do something to get a data collection across the Bay watershed? One of the more interesting recommendations that came out, we started to try to get a shell collection together, across the Bay watershed. And we realized it's actually really difficult to do because you have to have a permit to hold these shells because many of the shells are considered endangered species or threatened. And so essentially we've been working with the Smithsonian, and the concept, we've got to get some money together for this. We think it's going to happen, it may take a little longer because of COVID, but we're going to get a collection of all the shells that the Smithsonian holds for the Bay watershed and essentially replicate them or get them scanned by a PhD student that does this work and then replicate them. They can be replicated with a 3D printer. And so essentially anybody in the watershed can be given access to this database and just print their own copy of freshwater shells to use as a demonstration tool to talk about the organisms. So I'm really hopeful that's going to happen because I've seen some of the shells that they've done in the past and they look really like, and I think it could be a great educational tool. So the second consensus agreement was that the water quality benefit, particularly the nitrogen thing, it's real. It's not zero. The research is there to support that it exists. But that said, there are a lot of questions about, like how to, how much exactly is it? How should this be incorporated into the process? But essentially the recommendation there was the ecosystem services are real. These things are good for water quality. We should incorporate it, but there's some important research questions to figure out before we can get into that. The third recommendation or consensus kind of agreement was that, what we're doing for bay restoration, that has impacts on freshwater mussels. Some of them are really positive impacts. Riparian forested buffers certainly have an impact on freshwater mussels. They're really good for them. But there are some things that we're doing that, maybe they're not exclusively bad for mussels, but if they're done a certain way, they might be more protective. And a good example of that is stream restoration, where essentially urban streams that are scoured out, when they're rebuilt, right now, that doesn't necessarily explicitly consider outcomes for freshwater mussels. And so the group is working on developing some strategies on that front. And then the last thing that the group decided was that we really need to tell the story of mussels to people, and that mussels they're part of what we're trying to protect with the Chesapeake Bay restoration. We're protecting the entire watershed. We're restoring the entire watershed. And these organisms are ubiquitous. They're common around all the non-tidal waters of the Bay watershed. And when you think about the Bay watershed that's shown here, and this gets back to the question of, what the biomass is of freshwater mussels versus oysters, the number of people that have freshwater mussels in their backyard stream is a lot greater likely than the number of people that have oysters or crabs in their backyard. And so the recommendation essentially was that, we need to and I think kind of the underlying agreement here was that critters are often what hooks people. And people hear about an aquatic life that they care about that lives close to them and they want to protect it. And so the group, I think, felt like we should use that, because freshwater mussels are so common throughout the watershed. Okay. So, Anne, do you want to go ahead and tee up the last question as I go over this last slide? So what you can do, if you want to be involved in this process, I'd say the first thing is tell somebody about freshwater mussels. I can't tell you how many people I've talked to, and this includes like, PhDs in ecology that essentially, they've never even heard of freshwater mussels. They don't know that they exist. And so I think the most important thing anybody can do is just talk to somebody about this. It's a pretty cool conversation to have too, just over, drinks or something. The second thing I'd say is, consider your own backyard. Everybody lives in a watershed somewhere, some watershed. And the things that you do at your own house have an impact on water quality, whether that's, over fertilizing your lawn or pesticides or herbicides or, planting trees. And so take care of your own yard. And then the last thing is stay tuned. I'd say that we're really looking to find volunteer activities or ways to involve freshwater mussel restoration with citizens. It's sort of challenging. There's some of this new stuff that's still not quite figured out, but we are certainly trying to figure out opportunities. And so the last question was, would your organization or would you be interested in being involved? And it looks like most of you said yes. Some of you want to know more, and a few of you are probably not interested in this. So I think that's the last slide I have. I just need to thank a few of the people that contributed here and give a disclaimer. I'm not actually a mussel expert. I did my PhD on shellfish, on a species that not many people care about, the Rangia clam. So it's kind of, suited well for this topic. But there are a lot of experts that I've worked with that much of this research that I've shared with you is their research. So I want to give thanks to them and move into, I can go through some questions if there are any remaining questions.
Yeah, Joe, you can pull them up. You've got them.
Okay.
So do you see Bill Berry's question?
Yeah, I do.
Okay.
So do Unionidae mussels attach to cold water species such as trout or more warm water species? And I'd say it's sort of across the board and probably depends on where you are. The only classification I've heard that makes it, what I'd say is this, is that anadromous fish, I think, are theoretically a little bit better, or at least evolutionary ecologists think they're better because they move more. And so like from a distribution mechanism, they're thought to be a little bit better. Okay, second one, Anacostia Watershed Society. We keep juvenile native mussels in tanks for short periods of time as part of their mussel power program. And they work with Harrison Lake Fish Hatchery, so it's definitely possible to keep native mussels in tanks. So thanks to the Anacostia Watershed Society, there's some really cool stuff that they're doing that I think a lot of us can learn from. Um, Next comment here. There have been a lot of citizen science initiatives lately, iNaturalist, etc. Is the process of looking for mussels poking around a stream likely to harm them? What happens if you pull them out of a stream and then put them back in? And I don't know exactly the answer to that. We did have this conversation of like, well, could you get citizen scientists to go survey for freshwater mussels? And I think what most of the mussel biologists felt like was that that's a pretty difficult training exercise because they are so difficult to find. I think they might be a little bit worried about pulling them in and out of the water, although, you know, if you weren't dealing with something that was endangered, I think that generally they would probably be okay. But that's the type of question we're thinking about in terms of what can you do. Some of the other ideas that have been floated is like, you know, could we have caged mussels deployed at various sites that are sort of like test release that you keep in a cage, and see, you know, can they even survive in this water body before we go through with a big stocking. And Okay. So next question. Are you, I'm sorry, losing my train of thought here. Another concept that's been developed is some of these mussels are tagged. Essentially, they have these little, you know, coder tags inside of them, and you go around with a scanning tool, and you take your, basically what looks like a metal detector and wait for it to beep. And so one of the concepts floated is, could you take volunteers to a site where, you know, they've already been deployed for a few years and see if they can find them so we can study the survival? That's another concept. Okay, last question. Are you aware of grant opportunities that go towards furthering the cause of freshwater mussels? Yeah, so that's an interesting question. One of the things that, you know, this group, there was someone from NIFWIF, which does a lot of grant work with the Bay Program and around the country. And one of the points that the group made was that mussels is actually not considered today as a direct endpoint related to the grants that they fund. Part of that is related to them being called out as specific work items in some of the Chesapeake Bay Program's work. And so I think the goal of this, you know, workshop, one of the things that we're hoping that will happen is that'll be more possible in the future. And there are probably a few other opportunities out there, but NIFWIF is probably the best. They have funded some stuff, and I think that, you know, there are some places in the watershed that have gotten grants to do mussel work. And then I think this is probably the last one we have time for. I know we're a little bit over time. Do you have any information on how we can volunteer on mussel research? Books, blogs on information we can do in our own backyard to help mitigate. So Lindsay, if you send me a note, I'll be happy to share what I've got. And I'd say also that stay tuned. We're trying to figure out some of those questions.
Great.
Okay.
So thank you so much. And thank you all for being on the phone. You stuck with us for the whole hour. We really appreciate that. Our next webinar for next month is about plastics and microplastics and their impact on the health of the critters and humans in the Bay watershed. So be on the lookout for that one. And thank you so much for joining us. See you later.
Thank you.